Hello, welcome all to Anudeep YourStudyBuddy. Today we are going to start with the second part of line and planes. We are going to discuss about the plane in detail. So let us understand few basic before we proceed. Plane. Equation of plane. A plane is a surface such that the line joining any 2 points on it lies entirely on it. Plane can be determined by two intersecting lines, two parallel lines, a line and a point outside it, three non-collinear points. With all these things, we are able to write the equation of plane. Equation of plane passing through a point and perpendicular to a vector. Equation of plane passing through point A and perpendicular to the vector n is given by r dot n equal to a dot n. Equation of r dot n equal to a dot n is also called vector equation in scalar product form. If a dot n equals to d, then the equation r dot n will reduce to a dot n and it will take the form r dot n equal to d. Cartesian form. The equation of the plane passing through the point A x1, y1, z1 and the direction ratios of whose normals are a, b, c is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. The vector equation of the plane passing through the point A and parallel to a non-zero and non-parallel vector B and C is given by r minus a vector dot b cross c equals to 0. The vector equation of the plane passing through non-collinear points A, B, C is given by r minus a dot b minus a cross c minus a equals to 0. The normal form of equation of a plane is given by r dot n hat equals to p. Equation of plane passing through the intersection of two planes is given by a1x plus b1y plus c1z plus d1 equal to 0 and a2x plus b2y plus c2z plus d2 equal to 0. If these two are the equation of two planes, then the plane which is at the intersection will be given by a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2 equal to 0. The angle between two planes is given by cos theta equal to n1 dot n2 upon mod of n1 into mod of n2. And angle between a line and a plane is given by sin theta equal to b1 dot n upon modulus of b dot modulus of n. Two lines are said to be coplanar if and only if the determinant giving on the screen is it is equal to 0. The distance of a point P alpha from the line R is equal to a plus lambda b is given by alpha minus a vector the whole square minus alpha minus a dot b vector upon modulus of b the whole square. So if you have to evaluate two terms separately, subtract them and then you have to take the square root. The shortest distance between the lines is given by d is equal to a2 minus a1 dot b1 cross b2 upon magnitude of b1 cross b2. Question 1. Find the vector equation of the plane passing through the points a1, 1, 2, b0, 2, 3 and c4, 5, 6. So these are the non-collinear points for which we need to find out the vector equation. Let us solve this problem. Here you have been given 3 points A, B and C and you have been asked to find the vector equation of the plane. So the plane is given by r dot n equal to a dot n where n is a normal to the plane. So if I want to find out the normal to the plane for the given points, I can use the position vectors for the point A, B, C and B minus A cross C minus A will be giving me n which is normal to the plane. So let me assume let A, B, C be the position vectors for the points A, B and C. Therefore, A vector will be equal to I plus j plus 2k. B vector 0i plus 2j plus 3k. C vector equal to 4i plus 5j plus 6k. So after evaluation, B minus A is minus I plus j plus k. C minus A is equal to 3i plus 4j plus 4k. Now let us evaluate what is a normal. So here n vector is equal to B minus A cross C minus A, which will be equal to I, j, k, and it will be minus 1, 1, 1, 3, 4, 4. Now, after calculating what is n vector, let us use the formula to find the equation of plane. So, required equation of plane is given by r dot n equal to a dot n. So, now we have just now obtained the value of n, and that is equal to 7j minus 7k. A vector, as you know, it was I plus j plus 2k into, again n vector is 7j minus 7k. So it will be equal to, that is 1 into 7 giving me 7, and minus 14, that is equal to minus 7. So r dot 7j minus k equal to 7. This is the required equation of the plane. Find the vector equation of the plane which is at a distance of 6 units from the origin and to which the vector 2i minus j plus 2k is normal. Let us solve the second problem. Here you have been given that a required plane is at a distance of 6 units from the origin and the vector n, that is a normal, is 2i minus j plus 2k. That is the value of normal is given to you and a distance is given to you. In such a case, we can use the direct formula where we have r into unit normal vector n equal to d, where d is a distance of a plane from the origin. So here let us calculate what is n hat, that is n vector upon mod of n. So n vector is 2i minus j plus 2k, and it will be square root of modulus of n will be 4 plus 1 plus 4. So that means what I am getting here is 2i minus j plus 2k upon square root of 9, that is 3. And now the required equation of plane, it will be r dot normal equal to d. So r vector as it is. Now our n hat, that is 2i minus j plus 2k upon 3, it is equal to d is our 6 unit, that is 6. So it is nothing but r dot 2i minus j plus 2k. I am just transferring 3 on the other side, that is 18. This is what is the required equation of the plane, which is 6 unit from the origin. So this question may be asked for the 2 marks. Question 3. Find the angle between the planes r dot I plus j minus 2k equals to 8 and r dot minus 2i plus j plus k equals to 3. So let us evaluate the next problem. Here you have been given the two equations, vector equation of the plane. So there are two equations which are in the form of r dot I plus j minus 2k equal to 8. That is, it is in the form of r dot n vector equal to d. So here you have been given the two equations of the plane and you have been asked to calculate what is the angle between these two planes. So for this we can use the formula, that is cos theta is equal to n1 dot n2, where n1 and n2, these are the two normals for the respective equation of the plane given to us. So here let me assign n1 vector equal to I plus j minus 2k and n2 vector equal to minus 2i plus j plus k. So here what will be the modulus of n1 vector? As you can guess, it is 1 square plus 1 square plus 2 square, that it is equal to 6 root 6. Similarly, what is the value of modulus of n2? It is again 4 plus 1 plus 1, again it is same as root 6. Now, cos theta is the acute angle between these two planes, and we are going to find out by the formula of cos theta. It is equal to, let me rewrite the formula, n1 dot n2 upon mod of n1 dot mod of n2. Let us substitute the values. So n1 dot n2 will be mod of I plus j minus 2k dot minus 2I plus j plus k upon modulus of these two will be with 6. So it is equal to, it is a1 a2 b1 b2 c1 c2, so minus 2 plus 1 minus 2 upon 6. So what I am getting is minus 4 plus 1, that is minus 3 by 6. That is equal to, after the modulus sign, we can neglect the negative sign, so I am getting 1 by 2. So here we are getting cos theta is equal to 1 by 2. Therefore, theta equal to pi by 3, that is 60 degrees. So this is how they are very simple problem if you remember the formulas. So we can calculate the different types of equations for the given plane depending upon what is given in the problem. You can work out the problem on planes. If you find this video helpful, please like, comment and share, and please click on the bell icon. Stay tuned for the interesting video which is coming up very soon. Thank you.